Hi guys, I'm back with example 5 on using the implicit differentiation technique. Guys, again, we can see here the left hand side is a combination of x's and y's together. And also looking at this equation carefully, we can also realize, or we can also see that it is almost impossible to actually explicitly solve this for variable y. So guys, without even trying to solve for y, what we're going to do here, we're again going to use the idea of an implicit differentiation. But keep in mind here, we are not just trying to find the first derivative or just the derivative of y. We want to find y double prime of x, which obviously means we want to evaluate the second derivative of the variable y. And then we have the given point for which x is -2 and y is 0. So we got to finally evaluate the second derivative for this particular equation, which is like finding y double prime, but at point x equal to -2. Guys, this x is -2 here. Well, in this case, we may not really need or see that we need a y here, but when we actually do all the steps and write out all the steps, we will see all the way at the end, we will definitely need to substitute the value for the y as well. And if you have already practiced or seen my videos on implicit differentiation technique, you already know that on the right hand side, when we finally evaluate dy over dx, we get a y variable as well, in addition to getting x and maybe some other constant. So guys, for this particular example, I am also going to show you my way or my tricks or my techniques of doing it, which you might find easier or simpler than the other traditional methods that the textbook uses, or maybe if you have already learned it from in your classrooms or some other place, my method might be slightly easier for you. And guys, you can check out my method as well. So the first step for dealing with implicit functions when we are trying to find the derivative is to actually take the derivative on both sides. So if I do take the derivative on both sides, keep in mind guys, this whole idea of implicit differentiation is basically using the chain rule. So let me start by taking the derivative on both sides. So I like to write the steps here, d over dx of y square plus sine y, and then I have x square. When I take the derivative of the right hand side, we already know that the derivative of a constant is 0. So I'm going to write a 0 here. Then moving on, guys, there's three quantities on the left hand side. So we're going to break it down as d over dx of the first term plus d over dx of the second term. And then I have d over dx of the third term, x squared, is still equal to 0. Okay. So from here, guys, this y double prime x is same as d2y over dx2, if you want to think of this, or if you like to think of this as an d over dx notation. So keep that in mind. From here, guys, now we have to start actually applying the derivative or using the chain rule or whatever is the appropriate rule that one needs to use. So obviously for this one, we understand and we know that y is the function of x. So since y is a function of x, here we have to use the chain rule. And the other reason is that we don't have an explicit formula for y. So one has to just use the chain rule and write the notation pieces wherever one can fit in those notations. So here one has to use that first. So it is 2 times y, basically just using the power rule and then multiplying by the derivative of the inner. So it's like y squared, so it's just multiplying by dy over dx. dy over dx. Guys, this guy right here, again, one has to use the chain rule. But before using actually the chain rule, one first has to write the derivative of the sine function. We know the derivative of the sine is just a simple cosine. So we're going to write cosine of y. But in this case, we cannot just stop right here. We have to multiply by the derivative of the inner. In this case, it is not, I mean, it's really easy, which is just dy over dx, because this y is like an inner here. Guys, the third one is like the simplest one. It is the derivative of x squared with respect to dx. All we have to use for that one is just the simple power rule, x to the power n. So it's just going to be plus 2x equal to 0. Okay. So guys, this is taking the first derivative. So I'm going to preserve this equation, and we should preserve this equation. What we need to do now is, since we are not only interested in evaluating the dy over dx, we want the second derivative. That means we have to take one more derivative of this this equation. Guys, here's where like I may sometimes, like my technique is slightly different than what I usually see in the textbook. And again, there is two options. I mean, you are free to use any option you like. Guys, one of the options here is that we have been doing so far in my 4 examples, and if you have already working on implicit functions, you must be doing it as well. And that technique is that from this equation, you isolate the dy over dx and you try to bring everything else to the right hand side, and finally you solve for dy over dx. Guys, that is one way to go. You just isolate the y prime or dy over dx, then you will have your dy over dx. To get the second derivative, you just take the second derivative, you just take the derivative of that function and you will get the second derivative. Once you get the second derivative, then you evaluate that at that point. Guys, that is one way to go. But I feel like that is going to be slightly extra work and a little bit more tricky. I mean, it's not difficult, but you can still do it. But I feel like there's an easier way than actually going like trying to solve for dy over dx explicitly and then taking the derivative again. So for me, guys, the easier way is like this. I don't solve this for dy over dx. I leave it like this, but I preserve this equation. I preserve it like that. What I do is I again take the derivative of this whole equation one more time. So it's like similar to how I started with the first step of taking the derivative of the given equation right away, because I realized we could see that it's an implicit function. So with implicit functions, our first step is to take the derivative on both sides. That is what we did initially here. So guys, I'm just going to follow the same procedure with this equation as well. Again, because it's not an explicitly written out equation, although we can solve for dy over dx, but what I'm trying to say here is that is going to be some extra work, okay? So just follow my steps and you will see why I want to do, instead of just solving for dy over dx, why I just want to take the derivative of this equation, okay? So if I take the derivative of this equation, this is how it's going to look like. Guys, this, so I mean, maybe I should write the first step. So it's d over dx of 2y times dy over dx, and then plus, so I'm already like, since I'm taking derivative, I know what, like I have to distribute the derivative to each individual piece, so I'm already doing it. And because I don't have so much space here, so guys, I'm just trying to save some time and space here. So d over dx of the cosine y times dy over dx, and then the derivative of this 2x, guys, I don't have to really write the notation. We know that the derivative of 2x is just 2. If it is like, we have already done that so many times, so I don't have to really write the notation for that. The only two pieces that are really challenging here for me are these two pieces. Guys, with this one, again, we have a product of 2, again a product of 2. So let us simplify or apply derivative on these two carefully, step by step. Guys, the first thing that I'm going to do is I'm going to just take out this 2. So if I take out this 2, and then it's going to be d over dx of y times, maybe, you know what, I'm going to use a different color for these inside the parentheses, y times dy over dx, okay, and then plus d over dx. This one I'm just rewriting it. So cosine y times, guys, it is usually a good idea to like apply derivatives to both of these at the same time, and not like apply to one of them and not apply to the other one. So from here to here, yes, I only did something to this first term. With this, I just rewrote it, but that is how you should do things, so that we are consistent and we don't make any mistakes. Guys, I think from here I have to get rid of some of the stuff so that I can take it up and see how to simplify these derivatives. So let me get rid of, let us see what I can, well, I may have to get rid of this. I have to get rid of this. And then I will try to simplify. We already know that y double prime x is like d2x over dx square, if we want to write it in a d over dx notation. So guys, from here, let me take it up. From here, guys, you have to understand that this is the product of two functions. Same thing here, product of two functions. Okay. Now we have to use the product rule for this. Guys, 2 stays. The product rule for this means it's going to be dy over dx. So please look carefully. It is going to be dy over dx. Why? Because you have to take the derivative of the f, which is just dy over dx. We don't know its value. We're just going to write the notation for it. Then multiply by the g function, and g function is already like a dy over dx, but I mean whatever it is, we just have to multiply with that dy over dx. That takes care of the first half, because we know, let me remind you here, it's f prime times g plus g prime times f. Now I have to take the derivative of g. Guys, there's already a dy over dx, so if I take the derivative again, then it would be d2y over dx squared, and that is exactly what we want, the second derivative. Okay, so I'm going to kind of put it in a dotted circle because that is exactly what we want to evaluate. Guys, I cannot just stop right here. I have to multiply this guy with f function, which is just y. That takes care of the derivative of the product of these two. Now let us move on to the next piece. Again, the product rule, guys, cosine y times dy over dx. So first I have to find the derivative of the cosine, which I know is negative sine. And then this has to be multiplied by just the g function, dy over dx. dy over dx. Okay, we got that. And then there's a plus. Then I have to do the g prime. G prime again is taking the derivative of the derivative, which means we are going to get the second derivative. Let me write that. d2y over dx2. That would be the derivative of this already dy over dx function, but then one has to multiply again by the f function, which is just the cosine of y. I'm going to close it, right? Guys, I started a parenthesis here, I closed it. I was going to get two terms when I use the product rule. Close that with the parentheses. What else do I have? I have let me get some more space here. Guys, because I want to try to write this in just one line. It's easier for us to understand if everything is written out in just one line. So plus 2 equals to 0. Okay. So I think we are almost done with applying the derivative second time and actually executing that step. That is all. We are not going to take the derivative anymore because all we needed was y double prime, and we can already see y double prime here as well as here. So we got to stop here as far as the taking derivative piece is concerned. So guys, what I'm going to do is, first of all, I'm going to write this in a slightly user-friendly way, which is instead of writing dy over dx or d2y over dx2, I'm going to replace those by prime notations. Guys, if you wanted to start here with the prime notation, I have no problems with it. But what I find from my experiences with working with students for so many years, sometimes we get confused with those y prime notations, and then we may not be able to see a clear picture of this. So that is why I always like to start with dy over dx notation. And when I again apply the derivative, I would sometimes change it to y prime, or I would mostly leave it like dy over dx. Finally, when I get to this form, now I would just do one thing. I will just replace dy over dx by, we already know dy over dx is just y prime. So now I'm going to replace it with y prime times, again, y prime times y prime, because it is just dy over dx times itself. And then guys, plus this guy we already know is nothing but the y double prime, the second derivative of y function. So y double prime times y. Okay, and then same thing I'm going to do here, plus there is a negative sine y, and then dy over dx, I'm going to just replace it with y prime. Just for convenience, guys. I mean, if you don't want to replace it with y primes and you want to leave it as dy over dx, that is fine, as long as you understand that dy over dx is y prime and d2y over dx2 is y double prime, and we are trying to evaluate the y double prime. And guys, this guy obviously is y double prime times the cosine of y. Please don't forget there is still a plus 2. Okay, so guys, these are the two most important equations for this particular problem. So I'm boxing this one as well. Okay, and I don't want to lose any of these equations because I need both of these equations to solve for or to evaluate y double prime x. So I'm going to leave them, but I'm going to get rid of this. Let us see now what we need to do. Guys, let us look at, well, you know what, if we can also rewrite this dy over dx with y prime, let us actually do that. So guys, this is going to be, well, I'm going to change it right here again because I don't have space, otherwise I would have written it here. It's like y prime, and guys, again, same thing here, it's y prime. So now let us just focus on these two particular equations. Keep in mind, what I actually want to evaluate for is y double prime. Guys, from here, we had two options. One was to actually solve this for y prime and then find the derivative again. That was one of the options. Guys, we did not take that route. Why? Because there was going to be extra work and extra steps. But when I saw this problem in the textbook, they like to use that method of like solving this for y prime and then taking the derivative one more time, which requires extra work. It is not impossible. It is not like something that cannot be done, but it is extra work. So we did not take that route. What we did was we just applied derivative on both sides. When we apply the derivative on both sides, and we get an equation which looks like this, right? That's exactly what we did so far. Now, from here, looking at this messy equation and then looking back to what we want to evaluate, guys, we want to evaluate y double prime of x. So a common thing that anybody would do here is to try to actually eliminate or isolate y double prime, okay, and then try to get everything else on the right hand side. Now that is algebraically correct, and that is what the textbook also did. Guys, you can do it if you feel like doing it, but my suggestion is don't worry even about trying to isolate y double prime here. All you need to do is, we already have the values for x and y. So what we can do is, we can just substitute the values for x and y, and we can already simplify a lot of these terms. And finally, of course, at the end, if we have two y double primes or three y double primes, well, in this case, y double prime only occurs twice, so it's probably we're going to end up with two y double primes. But we won't have, once we substitute x equal to -2 and y equal to 0, we won't have to deal with these cosine functions and all that, because they would all be simplified to numbers, whether it's positive number, a 0, or a negative number. So it would be easier for us to work with that equation. So guys, my recommendation is at this step, okay, and these things, guys, comes with experience as well. So at this step, don't try to isolate y double prime, because one would think that we have to solve for y double prime, why not isolate y double prime? Yes, you can do that, but that may not be such a good idea for this, because it's going to make life a little bit more difficult for us, okay? So rather, just start substituting the values for x and y, and then we'll see how that simplifies and if it's going to actually help us to evaluate y double prime at x equal to -2. So that's exactly what I'm going to do here. So as soon as I decide to do that, guys, what I realized was, hey, I also need to substitute the values for y double prime here and then here again. So I still need to substitute y double prime. Do I have the y double prime value at x equal to -2? I don't, it's not provided to me. But guys, I have this equation, right? I have this equation. In this equation, without even trying to isolate y prime right away, if I substitute x and y values, I should be able to solve for y prime, yes, derivative of y with respect to x. So what I did here was, looking at this, I realized I need y prime. I went back to this equation. That's why I had already preserved it, and I knew that it is probably I'm going to need this again. So I substituted, what do I have for y? Y is 0. So 0 times y prime plus cosine of 0 times y prime plus 2 times x, x is negative 2. Guys, from here, 2 times 0 is 0, 0 times y prime is 0, this term vanishes. We know cosine of 0 is 1, and if you don't remember it, you can use the unit circle, or you can also use your calculator for that. So cosine of 0 is 1, 1 times y prime is just y prime, and that is going to be negative 4, and you can easily solve for y prime, so y prime is positive 4. So now I have the value for y prime as well from just substituting the given values for x and y in this equation. Again, it's an implicit function, implicit equation. Okay, guys, I think I have almost everything that I need to substitute back into this equation of interest, which will help us to solve for y double prime. Let us go ahead and simplify that. Guys, now I think I can, since we already solved this, I don't really need this equation anymore. All I'm going to write down here is that y prime equals to 4, and then guys, please allow me to get rid of this since I don't have too much space here. So all I needed from that equation was what was the value for y prime when x is negative 2 and y is 0. We have it. Let us go back and substitute values here. Guys, this is 2 times y prime times y prime. Y prime is 4. So it's like 4 times 4. What is 4 times 4? We can simply do that. 4 times 4 is 16. Plus, guys, y double prime. We don't know y double prime. That's what we are trying to evaluate. Times y. But what is my y? It's 0. So I will still write that step, but I know y double prime times 0, for at that matter, any quantity times 0 is going to be still 0. Plus, guys, let us look at this guy. It's negative sine of y, sine of 0, times y prime is 4. I'm just writing that step. Then again, y double prime, and then times cosine of y, which is cosine of 0, close the parentheses, plus 2 equal to 0. So it seems like that some of the terms are just going to go away. So let's see what goes away. Guys, from here I have 2 times, this is 0, so it's 2 times 16 plus, guys, sine of 0 is also 0. That means this whole term becomes 0, and I'm only left with here y double prime, and cosine of 0 is 1, so it's just y double prime times 1, which is just y double prime, plus positive 2 equal to 0. Guys, it simplified once we substitute values for y prime and the x and y. It just simplified to a simple equation, simple linear type of an equation. So it's 32 plus y double prime plus 2 equal to 0, implies that y double prime is, so 32 plus 2 is 34. So when I take it to the other side, negative 34. So guys, this is the final answer, or this is the value for the y double prime. And if you want to write it in a proper function notation, so let us write it in a function notation. So it is y double prime, because y is a function of x, and here this is also a function of x. Y double prime at x equals to negative 2 equals to negative 34. This would be a proper way of, actually a technical way of writing this final answer, but if you can also leave it like this, is negative 34. So guys, there were a lot of key things and techniques that one has to observe, and one has to understand and learn from this particular example. And when I looked at this example in the textbook, I could see that there's a possibility for a lot of things and concepts that I can share with you. So that's why I took up this problem, guys. Please keep in mind, if you see problems like this where you have to evaluate it at a certain point, and you have to find the second derivative, or for that matter just the first derivative, sometimes it may not be a good idea to just explicitly isolate or solve for a particular variable. Just keep working and try to do that all the way at the end. I mean, all the way at the end, yes, we had to isolate y double prime because that's what we wanted to find. So guys, take some time to go through this example and then practice this on your own so that you feel more confident with this one. Here, guys, I'm going to end this section with implicit differentiation. From my next videos, guys, I'm going to just choose some challenging problems from all these techniques, or all this whole section of finding the derivative of different functions, and we're going to look at some of those challenging problems. I'm sure it's going to be really fun and exciting. I mean, it is exciting for me to share these interesting and fun and challenging problems, so I hope you will also enjoy it and you will practice more of these on your own. Till then, guys, take care. I will see you next time.